CB for U1, Chapter 5, Session 10. This session we are going to solve questions from exercise 5.4. Question 1. Determine dy dx when y is x2 plus cosine of x plus sine of pi over 4. Derivative of x2 is 2x. Derivative of cosine of x is minus sine of x, and derivative of sine of pi over 4 is 0. Derivative of a constant is 0. Part J, derivative of y equals sine of 1 over x. Derivative of sine of u, when u is a function of x, is u prime cosine of u. Therefore, the derivative of 1 over x, which is negative 1 over x2, times cosine of 1 over x is the derivative of y equals sine of 1 over x. Question 2. Differentiate the following functions. Y equals ex times cosine of x plus sine of x. Dy dx equals derivative of ex times cosine of x plus sine of x plus derivative of cosine of x plus sine of x minus sine of x plus cosine of x times ex. If we factor ex, the answer would be ex times 2 cosine of x. Derivative of y equals cosine of sine of 2x is minus sine of 2x times 2 cosine of 2x, chain rule. Or we could say, if we call it u prime times minus sine of u. Part F, derivative of 2x3 sine of x minus 3x cosine of x. You have to apply product rule twice. Derivative of 2x3 is 6x2 times sine of x plus derivative of sine of x times 2x3 cosine of x times 2x3. We factor minus 3 and we have derivative of x1 times cosine of x minus sine of x times x. One more time, derivative of product of two functions is derivative of first function times second function itself plus derivative of second function times first function itself. The next question is question number 3. Determine an equation of the tangent line to the graph of f of x equals sine of 2x plus cosine of x when x is pi over 2. When x is pi over 2, f of pi over 2 is 0. Sine of pi is 0 and cosine of pi over 2 is 0. Derivative of the function is 2 cosine of 2x minus sine of x. When x is pi over 2, the slope m would be 2 cosine of pi, which is minus 2, minus sine of pi over 2, which is minus 1. The slope is negative 3. Y minus y1 equals m times x minus x1, the equation of the tangent line. Next question. Question 4, part B. If f of x equals sine squared of x and g of x equals 1 plus cosine squared of x, how are f prime of x and g prime of x are related? If we add up f of x and g of x, we have f of x plus g of x equals 1 plus sine squared of x plus cosine squared of x, which is 2. Now we take the derivative of from both sides of this equation. Therefore, f prime and g prime are opposite of each other. Next question, question number 5, part B. We are looking for derivative of Vt equals 1 plus cosine of t plus sine squared of t to the power of 1 over 2. V prime of 2 would be 1 over 2 times 1 plus cosine of t plus sine squared of t to the power of negative 1 over 2 times derivative of 1 plus cosine of t plus sine squared of t, which is minus sine of t plus 2 sine of t cosine of t. Part D, derivative of mx equals x2 plus cosine squared of x to the power of 3. We use power rule for functions. 3 times x2 plus cosine squared of x to the power of 2 times derivative of x2 plus cosine squared of x. Derivative of x2 is 2x. Derivative of cosine of x to the power of 2 is minus 2 cosine of x sine of x. Therefore, the derivative would be 3 times x2 plus cosine squared of x to the power of 2 times 2x minus 2 cosine of x sine of x. Next question, question number 8. A particle moves along a line so that at time t the position is st equals 8 sine of 2t. For what values of t does the particle change the direction? You have to see when velocity changes the sign. Velocity is 16 cosine of 2t. If you set velocity to 0, cosine of 2t would be 0. This means 2t is pi over 2, 3 pi over 2, 5 pi over 2, and so on. Therefore, t would be pi over 4, 3 pi over 4, and so on. What is the particle's maximum velocity? We are looking for maximum of Vt. Vt is at pi over 4, velocity is 8. At 3 pi over 8, the 3 pi over 4, velocity is negative 8. Velocity is positive between 0 and pi over 4, negative between pi over 4 and 3 pi over 4. Therefore, at t equals pi over 4, velocity is maximum. Next question, question number 12. An irrigation channel is constructed by bending a sheet of metal that is 3 meters wide, as shown in the diagram. What angle theta will maximize the cross-sectional area and therefore the capacity of the channel? If we label the diagram and call the end points A and D, DH and DKH, BH and CKX. Then cosine of theta is X in triangle AHB or the other triangle, and sine of theta is H. We know the area of trapezoid is the average of the bases times height. Therefore, area would be 1 plus 2x times h divided by 2, which can be written as, it is actually 2 plus. By looking at the diagram, we see one base is 1, BC. The other base is AB, which is 1 plus 2x. Therefore, sum of the bases is 2 plus 2x times h divided by 2, which is 1 plus x times h. This can be written as 1 plus cosine of theta times sine of theta. Theta is between 0 and pi over 2. We are looking for the maximum of A. dA d theta is, we can find the derivative using product rule, minus sine of theta times sine of theta, derivative of the first function times second function itself, plus 1 plus cosine of theta times cosine of theta. If we simplify the derivative, it is going to be minus sine squared of theta plus cosine squared of theta plus cosine of theta. Cosine squared of theta minus sine squared of theta can be written as 2 cosine squared of theta minus 1. Therefore, the area, the derivative of the area is 2 cosine squared of theta plus cosine of theta minus 1. This can be factored as cosine of theta minus 1 times cosine of theta plus 1. Between 0 and pi over 2, cosine of theta plus 1 is positive, and 2 cosine of theta minus 1 is 0 when theta is pi over 3. Now, we calculate area when theta is 0, pi over 3, and pi over 2, using the algorithm for maximum minimum of a function on a closed interval. At theta equals 0, area is 0. At theta equals pi over 3, area is 3 root 3 divided by 4. And at theta equals pi over 2, area is 1. Therefore, the area of the trapezoid is maximum when theta is pi over 3. Thanks for watching.